we have three components, right? So we have the Adafruit Feather M4 Express microcontroller. We have the Adafruit Ultimate GPS Featherwing. And then we have the Ouster OS-0 Series D model, I believe. And so they're all linked together. I'm not sure if the Feather, the microcontroller, is strictly necessary for this application, but we got to plug it in anyway to provide power via USB from the laptop. So I think these two leads are connected to this breadboard, which are into the, I believe, the 3 volt in the yellow and the ground line in the white, and then the RTX line is going into here. So the red is the TX output from the GPS sensor, and the blue is the RX from the microcontroller. This black lead is connected to the antenna, which connects to this thing. Yeah, and then this red line is just connected to this slot in the breadboard on the right side, just because I don't have a female to female jumper. Anyway, this red connects to this yellow, and this yellow connects to ultimately the Ouster board here. So this is in the sync pulse in spot in the Ouster interface board, I believe it's called. And then the blue here is the ground, so that's connected to the same ground that the microcontroller is connected to, the ground in the Featherwing, the GPS sensor. And then the white is the multi-purpose I/O, which when it's configured to input, I think it's called input NMEA in, something like that. Anyway, so it's taking the UART messages from the GPS. So this is coming out of the TX from the GPS board, and so that's running this white into the multi-purpose I/O. I believe I could probably plug this in directly into the TX on the board here rather than here, but then doing it this way makes sure that this is connected to the same place that the microcontroller is here. So this way I can monitor the microcontroller and the GPS independently from the Ouster, which I think will be helpful, so I can tell it's easier for troubleshooting. So sometimes the GPS sensor might lose signal, and then the Ouster obviously won't know what time it is because of that, and so we can troubleshoot the GPS signal independently from the Ouster this way. Yeah, and then so this USB cable will connect to the laptop, and then this Ethernet from the Ouster also connects to the laptop. And there we have it. Now we can have correctly time-stamped sensor data. Sync pulse in and NMEA both locked, and a timestamp. This timestamp right here, 168.9216813.950786, is actually a Unix timestamp and not a GPS timestamp. So it is correctly stamping the time based off of the GPS sensor. I figured it out. Everything's working. So next step is going to be to link this up to ROS, and we should be able to combine the GPS coordinates output with the Ouster sensor now. Now the next step is we can run RTABMap using the GPS coordinates as a sort of restriction on the possible locations and the Ouster LiDAR data together in order to create an accurate map of the point clouds.